Okay, so today we're doing the section 6.5, which is difference of squares and perfect square trinomials. So to really be successful at understanding this section, you should have some understanding of factoring, and so I do recommend that you go through my other factoring videos before you watch this one, because I'm going to be using those techniques. I'm not going to go deep into the details on how to do them. I'm going to assume that you have watched those videos already. So what is the difference of squares? So last week we talked about shortcuts for multiplying, and we had the sum and difference. And that was where you had something plus something times something minus something. So the difference of squares is the reverse of that. It's where you have the result and now you're factoring. So now you're breaking it up into the multiplication parts. So that is a squared minus b squared. So it's a difference, subtraction, and the two things are squared, hence the name. Now, we cannot factor something that's a sum of squares. If there's a plus in between, then we say that is prime. That is not factorable, but we can factor a difference. In order to use this shortcut, you really need to know your squares and your square roots. So you need to be able to recognize your perfect squares, which are numbers that you can take the square root of. So there's this table here that has all of the squares up to 15. The only one that I personally never remember is 14 squared. And then it also has some perfect squares when you have variables. So perfect squares that involve variables, you have to have an even power, because when you square something, you're basically multiplying by 2. So your variable, your exponent on a variable has to be divisible by 2 in order for it to be considered a perfect square. So I'm just going to go straight into different examples. I'm going to start with the trial and error method. So that is factoring trinomials of the form x squared. Oops, I thought I had my pen. Let me try that again. That's factoring trinomials of the form x squared plus bx plus c. So if you have not watched that video, I would do that first. And then I'm going to show the difference of squares method. So trial and error method, in this case, we have r squared minus 81. We don't have a middle term, so we can put in a 0. So that's r squared plus 0r minus 81. And these always factor to 2 sets of parentheses. And if you have your variable as r, then I'm going to have r. And r times r is r squared. So I'm always going to have that in the first term. And now I need to figure out, and I'm going to use my highlighter here to figure out, we need two numbers that are going to go into these last two spots so that we can make this multiply correctly back to where we started. If we are multiplying to a negative, that means we need to have a positive and a negative. So I'm going to already put in the plus and the minus. So I'm looking for two numbers that will multiply to my last term, which is 81. And then because they have opposite signs, when you subtract them, basically one's added, one's minus, they are going to combine to the middle term, 0. So I need two numbers that multiply to 81, a positive and a negative, and then add to 0. So they have to be, in order to get to 0, they need to be the same number. So that would be 9 times 9. So 9 times 9 is 81. And then 9 minus 9, or 9 plus negative 9, that gets me 0. So that is factoring this using trial and error, where you're basically just using some thinking skills and figuring out what are the numbers that you need in order to make this work. Now the difference of squares method, and I'm going to write down this formula, a squared minus b squared equals a plus b times a minus b. So you just have to identify what your a and your b are. So we have r squared minus 81. And so r squared is literally r squared, and then 81 is 9 squared. So I'm using my highlighter here. A goes in the first spot, so our A is r, and then B is the last number, and that's going to be 9. So you literally write r plus 9, r minus 9. So you get the same answer. Usually with the difference of squares, I go straight to the answer, and so I just do it in one step, because I know in order for the middle to disappear, they have to be the same number, opposite signs. Now I'm going to take a look at example 2. So we have 4a squared minus 121b squared. If there is a number in front of your first term, then we don't usually use trial and error, we use the AC method. In order to use this method, I need to put in that middle term, which is going to be 0, and then it has to be a combination of both variables. So that's going to be a, b, and then I have minus 121b squared. So the AC method, how that works is that you are taking your first term, which is a, and your last term, c, and you are multiplying those together. So I am going to do that in a different color here. So 4 times negative 121, and I need to take out my calculator for this. I got negative 484. Now I need to figure out a combination of two numbers that multiply to negative 484 and add to 0, because I have to add to that middle term. And so I need to figure out what combination can get me there. So I need a positive and a negative number, and they need to be the same number in order to cancel out to 0. So if I take the square root of 484 and ignore the negative, that gives me 22. So that will tell me that I need to have a positive 22 and a negative 22. Those will multiply to negative 484 and then add to 0. So once I've determined those numbers, then I have to rewrite my expression. And so I'm going to have 4a squared plus 22ab plus negative 22ab. And then let's just make that a plus negative 121b squared. So the middle term is ab, so that's why I have 22ab and minus 22ab. Then I need to group the first two and the last two together. And then I start factoring out the greatest common factor. So in the first pair, I'm looking for the largest number I can divide out of 4 and 22. And that's going to be 2. And then I compare my variables. I have an a squared and an a. You always take the one with the smallest exponent, so that's a. And then I have no b and b, so smallest exponent would be that there's no b at all. And now I divide 2a out of each of these terms. So 4 divided by 2 is 2. A squared divided by a is a. Then 22 divided by 2 is 11. A divided by a is 1, so we're going to just leave that off. And then I have b. Now on the second pair, because my starting part is a negative, I negative 22, I need to also factor out a negative. And now I'm looking for the largest number that divides out of 22 and negative 121. And I know 11 comes out of both of those, so I'm going to factor out an 11. Then I look at my variables. I have a and no a, so I don't take an a. And then I have b and b squared, so the smallest exponent would be b. And now I divide each term by negative 11b. So negative 22 divided by negative 11 is a positive 2. I have an a, and then b divided by b is 1, so that cancels. Then I have a negative 121 divided by a negative 11, and that comes out to a positive 11. B squared divided by b is a single b. Now you know you've got the AC method correct when inside your sets of parentheses you have the same thing. So I pull those out. This gives me 2a plus 11b, and then I look at the beginning of each set of parentheses, what's in front, and that's 2a minus 11b. So that's factoring this with the AC method. Now let's do it with the difference of squares, and you'll see that the difference of squares actually makes this process faster. So again, with the difference of squares, we have a squared minus b squared equals a plus b times a minus b. So we have to identify our squares here. So basically you take the square root. The square root of 4 is 2, so that's a 2, and then a, and then squared, minus the square root of 121 is 11, and then a b, and then squared. You can't use the difference of squares if you take the square root and it comes out to a decimal. So you can use your calculator to figure this out. You're just taking the square root using your calculator. If it comes out to a decimal, then you can't use this shortcut. So now that I have identified my A's and B's, and I'm going to color code here. The 2A is going to be in the front, and then 11B is going to be in the back if you're following the color coding. So this gives me 2A plus 11B times 2A minus 11B. And I will highlight that so you can see that pattern. So another way, if I rewrite this rule with only highlights, so you can see the pattern, and you don't have to worry about the variables. We have the yellow squared, and then that's the yellow, which is in the front of each thing, and then green squared, which is in the back. And apparently green on blue looks like yellow, which doesn't quite make sense, but that's how it comes out. So we get the same answer either way. One way in this case is much easier to do than the other way. And so I actually do recommend everybody learn the difference of squares formula. That is the one shortcut that I think is well worth your time to learn, because it does show up a lot and it does save you some time. Next is example 3. These are some more complicated ones, and I'm going to do these both using the difference of square formula. So I'll write that again without the weird color changes. So the yellow is the first term, and the green is the last term. So the first one here, I have y to the 4th minus y squared. So y to the 4th, if it has that even exponent, we divide it by 2. So that's y squared squared. And then that is x squared. So that makes my green as x and my yellow as y squared. So when I put this into the formula, I end up with y squared plus x times y squared minus x. And that's all it is. Now let's look at the second one on the right here, 63 minus 7h squared. So if you take the square root of 63, you actually get a decimal. It does not come out evenly. And the same thing with 7. So we can't use this formula, the shortcut, directly. However, I can factor out 7 from our parentheses here. 63 divided by 7 is 9. 7 divided by 7 is 1. So that just leaves an h squared. So our greatest common factor here is 7. And then I can factor my 9 minus h squared. And so first I'm going to identify, I'm going to rewrite this. So 9 is 3 squared. And then of course I have an h squared. So this will help me identify my yellow is 3 and my green is h. So when I put this in the form, the 7 is going to stay in front. Then I have 3 plus h times 3 minus h. And then that is factored completely. Our next type of shortcut is the perfect square trinomial. So this is the reverse of the square of a binomial when we multiply that out. So now we're going the other direction. So it's a squared plus 2 times ab plus b squared, or a squared minus 2ab plus b squared. What I want to point out here is that it always has a plus b squared. So the first sign matches with whether it's going to be a plus or a minus when you factor it. Using this rule is harder for people. And so for something like this, I would say you're welcome to factor like normal because it's a lot harder for people to use this shortcut. So the steps are, first you determine whether your first and third terms are perfect squares. So you have to make sure that the first term and the last term you can take square roots. If you can't, then you need to factor like normal. If you can, then you need to make sure that your middle term is twice a times b. If it's not, then you can't use this. If it is, then you can use the shortcut. So I'm going to start here with a trial and error to show you to factor, and then the perfect square trinomial. So y squared minus 8t plus 16. So I don't have to add in any extra terms. I can go straight to my form. Because I have a y squared, I'm always going to have a y times a y. Whatever that variable is, and it's squared, that's always going to be in the beginning. And now I'm looking for two numbers that multiply to 16 and add to negative 8. If they're multiplying to a positive and adding to a negative, they both have to be negative because a negative times a negative is a positive. So 4 times 4 gets me 16. And then 4 plus 4 is 8. And with the minuses, that would be a negative 4 times a negative 4, and then negative 4 plus negative 4. So if you do this with trial and error, you get y minus 4 times y minus 4, which is completely fine to write your answer that way. But you can combine those because we have y minus 4 twice, and you can write this as y minus 4 squared. Now for the perfect square trinomial, we want to first identify that the first and last terms are squares. So 16 is 4 squared. So I have a y squared minus 8t plus 4 squared. And then you want to test whether 2 times your a and your b gives you the middle. So that's 2 times my y and 4. And when I multiply that, I get 8. Oops, I see that I have a t. That should be a y. I'm like, wait a minute here, my variables are different. That should be minus 8y. I should match those. Okay, so this would give me 8y. So I'm going to write, whoops, thought I was on my pen. I'm going to just write the formula here, plus or minus 2, because it could be a positive or you could get a negative version, plus or minus squared. So with the highlighter, oops, wrong one. So the last term is green. I'm using the same colors that I did in my multiplication video so that you can see the consistency here. So I have y, and then 4 as the last. And then I verified that 2 times the yellow times the green gave me that middle term, because that's what you need in order for these to match. So once you verify that that matches, then you can just go straight to your answer. So yellow, and because my middle is negative, that's going to be a minus. So minus the green squared. So that gives me y minus 4 squared. So you can see that this is actually a little more work than doing the trial and error, and it involves a little more thinking. But you get the same answer. Now here's another one, and I'm going to do this one in the AC method because I have a number in front of my p squared. And yes, this time my letters do match. So we have 36p squared plus 60p plus 25. So the AC method says that you take the first and the last numbers and you multiply those together. So 36 times 25. You definitely need a calculator for this. It gives me 900. And now I'm looking for 2 numbers that multiply to 900 and add to 60. Because I'm multiplying to a positive and adding to a positive, they're both going to be positive. Now looking at this, 3 times 3 gives me 9. 30 times 30 gives me 900. And then 30 plus 30 gives me 60. So those are going to be numbers. And you notice that there's 2 of them. So I'm going to rewrite my expression. I have 36p squared plus 30p plus 30p plus 25. And then I group the first 2 and the last 2. Now in the first pair, I need to get the biggest number I can divide out of 36 and 30. And that would be 6. And then I have a p squared and a p, so my greatest common factor would be p. That's the smallest exponent. So then I divide. 36 divided by 6 is 6. P squared divided by p leaves me another p. Then plus 30 divided by 6 is 5. P divided by p is 1, so I can leave that off. Now, the second pair, I'm looking at the largest number I can divide out of 30 and 25. And 5 goes into both 30 and 25. And then I have a p, but I have something without a p, so I can't factor out a p. So 30 divided by 5 is 6, and I'm left with a p. Then 25 divided by 5 is 5. So now I have the same thing in my sets of parentheses, which tells me I've done this correctly. So that gives me 6p plus 5 times another 6p plus 5, which comes from the front in each set of parentheses. And that gives me 6p plus 5 squared. And just for clarification, the second 6p from 5 is coming from what I've highlighted in yellow. The first 6p plus 5 is coming from the fact that the sets of parentheses match. So they're identical, but they're coming from different parts of the previous step. It's a little easier to understand the AC method when they're not identical like this. So now let's do this with the perfect square trinomial. So to use a perfect square trinomial, I need to first rewrite my first and last terms as squares. 36 is 6 squared, and then I have a p, so I can put 6p in parentheses and then the 2, plus 60p plus, and then 25 is 5 squared. So I've identified my first term and my last term. And I need to check whether the middle is 2 times the first term times the last term. So I need to double check that I have 2 times 6p times 5, and that gives me the middle. So 2 times 6 is 12, 12 times 5 is 60p. So that matches, which means that this is a perfect square trinomial, and I can go to my shortcut, which is going to be the first term plus, because the middle is a plus, and then the last term squared. I'm going to highlight, that's the first term plus the last term squared. So this does save you time, but there's nothing wrong with using the AC method as well to factor these like normal if you prefer that. I do think the difference of squares is the most important one to learn, but you do get the same answer factoring with your preferred method. Okay, so now I'm ending this with 2 more complicated ones that you may come across. Here we have 4 terms. So in order to factor this, we need to factor by grouping. So I'm going to rewrite this by grouping the first 2 together. So I have y cubed plus 6y squared. And then I'm going to group the last 2 together. So that's minus 4y plus negative 24. So now I need to factor out the greatest common factor. So y cubed and y squared, the smallest exponent is y squared. And then I can't divide any number from the y cubed because there's no number there. So y cubed divided by y squared, you're subtracting exponents, you have a single y. And then you have 6, and then the y squareds cancel. So that gives me y plus 6. Now the second set, because my first there, the minus 4y is negative, I'm going to factor out a negative. And then the largest number I can divide out of 4 and 24 is 4. And then I cannot take a variable because the 24 doesn't have a variable. So negative 4 divided by negative 4 is 1. So I'm all left with is the y. And then negative 24 divided by negative 4 is a positive 6. So now my first set is y plus 6, the part that matches in parentheses. My second set is what's in front of them, the y squared minus 4. But now I am not done because I have, with the y squared minus 4, this is a difference of squares. So I need to factor again. So when I do this, the y plus 6 is going to stay. And then I'm going to set up my 2 sets of parentheses because the difference of squares is pretty simple. You have a y times a y to get you your y squared. You have a positive and a negative, and then you need 2 numbers that multiply to 4 and then add to 0, which is 2 times 2. So that's a positive 2 times a negative 2 is that minus 4, they add to 0. And so now we are factored completely. So we have y plus 6 times y plus 2 times y minus 2. And now this example. So this one's tricky in the fact that you have something in parentheses squared and then minus 4. And so we're going to do this with another difference of squares. Oops, I meant to have the highlighter, not the pen. Let me go back to my highlighter. They've already put part of it in the right form because we have something in parentheses squared. So if I rewrite the form here, something in parentheses squared minus something in parentheses squared is that something plus the other something, and then that something minus the other something. So let's go back to my highlights. It's yellow squared minus green squared, which is yellow plus green times yellow minus green. So we already have the yellow. Now 4 is 2 squared, so that's going to give me my green. So when I'm looking at my highlighter, my yellow is going to be x minus 2, and then my green is going to be 2. So I'm actually going to put in the highlights first so that you can see this. Go to the yellow, so it's going to be the yellow in the front and green in the back. So now I'm going to fill it in. So yellow is x minus 2, and then the green is 2. So now I need to simplify. I have x minus 2 plus 2. So negative 2 plus 2 is 0, so I just have x. And then in my second one, negative 2 minus 2 is 4, so I have x minus 4. So I used the difference of two squares to factor, and then I simplified to give me my final answer. So the difference of squares, I really do recommend that you try to learn this one. It comes up a lot. Learning it by the pattern and the highlights will really help. The perfect square trinomial is a little harder because you have to do 2 times the first and last term, so it's a little harder to see the pattern there. So if you're not comfortable with those, you can just factor like normal. But the difference of squares, definitely one that I would recommend learning. So that's it. That's all I have. Don't be afraid to watch this again, to pause, work through the problems, write yourself some extra notes. Let me know if you have any questions. And definitely make sure you've watched all my other videos before this one so that this one will make much more sense. And I will talk to you guys later.